We're going on a trip in our favorite rocket ship, zooming through the sky, little Einstein.
Hello everyone, we are the Little Einstein. What we are about to show you is the importance of calculus in the two specific fields of engineering, which are chemical engineering and civil engineering. Engineering at its interplay of the finest language of mathematics. So how can calculus be applied in the fields of engineering? Well, it's applied through solving equations and know what needs to change in order to optimize the design. For us, math is complicated, very complicated, but we learned that studying mathematics and calculus allows us to prepare ourselves in solving complex problems. We can't just build an engines with algebra and not know where the heat goes. But calculus and differential equations do that. Now, let's connect calculus first and civil engineering. One of the oldest engineering disciplines, civil engineering, is the applied science of physics and mathematics to address the infrastructural needs of human civilizations. This type of engineering deals with constructed environment, including planning, designing and overseeing constructions and maintenance of building structures and facilities. These theoretical basis of most topics within this course have their basis in calculus. They used it to calculate forces, area, and volume. To mark this in your minds, we will give you an example problem showing a civil engineering problem that can be solved by calculus.
The side of the cube is increased at the rate of 5 cm per second. Find the rate of increase of the volume when the length of a side is 3 cm. Volume is equal to x cubed. Find the rate of change, volume, dV over dt, with respect to time. When x is equal to 3, the rate of change is going to be dx over dt is equal to 5. dV over dt is equal to dV over dx times dx over dt is equal to 3x squared times 5. Result is 15x squared is the rate of change of the volume with time. When x is equal to 3, dV over dt is equal to 15 times 3 squared is equal to 135 cm cubed per second.
Let us now move to the application or the significance of calculus in chemical engineering course. Chemical engineering is a branch of engineering that uses principles of chemistry, physics, mathematics, and economics to efficiently use, produce, transform, and transport chemicals, materials, and energy. This course also focused on training the students to design and operate equipment that they might find in chemical plants, such as pumps, reactors, and distillation towers. Chemical engineers use calculus when solving problems pertaining to mass transport, heat transport, momentum transport, thermodynamics, and reaction kinetics. Normally, calculus used for solving ordinary and partial differential equations, both numerically and analytically. To deepen these thoughts, here is some sample problems regarding to the connection of the two.
100 joules of heat is added to 25 grams of iron at a temperature of 15 degrees Celsius. What will be the final temperature? Specific heat is equal to 0.45 joules over gram times degree Celsius. The formula is heat is equal to mass times specific heat times change of temperature. Change of temperature is equal to heat divided by mass times specific heat. Change of temperature is equal to 200 joules divided by 25 grams times 0.45 joules over gram times degree Celsius. The result is change of temperature is equal to 17.78 degrees Celsius. What will be the final temperature? The final temperature minus the initial temperature is equal to 17.78 degrees Celsius. The final temperature is equal to 17.78 degrees Celsius plus the initial temperature. The final temperature is equal to 17.78 degrees Celsius plus 15 degrees Celsius. The result is the final temperature is equal to 32.78 degrees Celsius.
I gave a calorimetry equation for this one because I believe that calculus is just a higher math that needs deep comprehension and analysis. Those are the things that are needed to solve a calorimetry equation.